Assalamualaikum and good day everyone. We are the first year student of University Technology Malaysia UTM who are currently took Bachelor of Engineering in Geometry. We are required to take a subject called Engineering Survey with the code SBE 1043 in our second semester. This semester, our group is assigned with an engineering project which we need to conduct the engineering survey. We were given a project form which is 10 km tunnel underground for new speed train railway from the Iskandar to KLIA. My name is Nurbila Isa. This is my group member. Muhammad Faiz Akmal, Muhammad Zulaikal, Kaizatul Nazira and Arni Shazani. And our lecturer is Dr. Abdulwahid bin Rasid. Introduction. So, construction planning is a fundamental and challenging task in order of execution of construction project. A construction plan is a detailed comprehensive plan for a construction project. GCP1 is one of the crucial tasks in order to build the alignment of high-speed railways. For the GCP1, there are two phases of monument that need to be established, which are the first order and the second order monument. But in our case, the first order monument has been already established and the tunnel construction has been completed. Therefore, our group will explain the second order monument, or we call it as a post order monument. Since our construction plan is a comprehensive plan, it gives advantage to see a clear step-by-step process to follow and ensure that each phase of the project is executed in the proper order. Therefore, the group plan will maximize the efficiency and eliminate any possible need for work to be repeated if a task is completed outside its proper order. The main task is to understand how to deliver and implement the various engineering survey projects which involve the choice of technology, the duration of for the individual tasks, and the identification of any interaction among the different work tasks. Since GCP1 is one of the crucial tasks in order to put the alignment of high-speed railways, it can identify the project duration. For the GCP1, there are two phases of monument that need to be established, which are the first order and the second order monument. GCP1 identify the area to construct the first order monument, also the location of the first order monument marker to be construction. This need to be accessible at all times and close to public access road. At each boundary between two states within the geographical area, each boundary between the two states has at least two first-order monuments in each state that are subject to the distance between these two first-order monuments. However, as I mentioned earlier, in our case, the first-order monument has been already established and the tunnel construction has been completed. Therefore, our group will conduct the second-order monument, or we call it as a post-order monument. One of the criteria in GCP1 is that the monument itself must hold for 20 years. Thus, the location of the monument must be safe from vandalism and hazard areas. Next is the objective. The first objective is to establish the second-order ground control point by carrying out the control traverse. This method is carried out by using the total station. Next is to carry out leveling for height transfer for all ground control points for second order from benchmark of the first order. Then we need to carry out detail and spot survey for tachyometry for the tunnel and to produce as-built drawing for the tunnel by using the AutoCAD.
Assalamualaikum and salam sejahtera. My name is Muhammad Zulaikal and I'm from Group 4. So today I would like to present about the scope of work of our group project. The title of our group project is 10 kilometers underground tunnel speed train from Iskandar to KLIA. So we go first to the project overview. The bilateral agreement from the KL to Singapore HSR was recently signed by the Government of Malaysia and the Government of the Republic of Singapore on 13 December 2016. The Kuala Lumpur to Singapore High Speed Rail HSR is a strategic project that will expected to significantly improve connectivity and synergies between the two countries by reducing travel time between Kuala Lumpur and Singapore. The Kuala Lumpur to Singapore High-Speed Rail (HSR) will use dedicated tracks with an alignment of approximately 350 kilometers, 335 kilometers being in Malaysia, allowing the express service travel within 90 minutes. Region station will be located in Bandar Malaysia, Putrajaya, Seremban, Air Keroh, Muar, Berhad and Iskandar Puteri. Singapore's station will be located in Jurong East. However, in this report, only focusing on 10 kilometers tunnel high-speed rail from Iskandar to KLIE. The Kuala Lumpur to Singapore High-Speed Rail (HSR) project grid is expected to use geocentric Malaysian rectified skew automorphic (GMRS) throughout the entire alignment in Malaysian territory, traversing two different geocentric Cassini shoulder (GCS) to respective states, namely Federal Territory Kuala Lumpur, Selangor, Federal Territory Putrajaya, Negeri Sembilan, Melaka and Johor. The Malaysian nation grid will interface with the Singapore national grid at the Malaysia-Singapore international border. So we go to the next, which is project scope. The scope of work that will be taken by the contractors, which is the company will of this project, in conducting the GCP01 project. The general scopes within the ground control point for package 01 geographical are outlined as follow. The first one is to establish a common point of reference for each state boundary. The second one is to install and construct the GCP monuments based on the respective categories. The third one is to identify the location of the monuments to be constructed. Or to prepare the overall GCP monuments, including the location and the plans within GCP01 package area, which shall be subject to the agreements of MyHSR and relevant authorities. And the last one is to provide reference network input. So we go for the third one, is project deliverable. Project deliverable is something that the from our side to give to our client. What is the output that we will give for them? So the first one is design calculation of second order monument. The second one is second order monument drawing. And the third one is prepare the overall GCP monuments, including the location and plans, which is the final product of our to our client. So we go for the first one is design calculation of second order monument. As you can see from the slide, all the factors that will contribute to the monument is put in the calculation. All the factors such as all the rain and all the heat that will affect the monument is put in the calculation so that there is no problem occur in the future. For example, as you can see for the first one, as they calculate the size and the length of the monument, and also their serviceability limit state, ultimate limit state, characteristic strengths of the material used, and the bending reinforcement design, and also normal shear and punching shear around column face, and also cracking. All these all these factors that we contribute for the second order monument in the future is calculated so that all the problem occur can be solved. And let's go for the second order monument. So this is the A3 drawing of second order monument drawing. As you can see, the drawing is very detailed so that all the calculation and material use can be estimated by it. So this is the second order monument that we use to will use in the GCP on the Earth's surface. And the last one is prepare the overall GCP monument including the location and plans. So this is the aerial view of our tunnel, aerial view of our tunnel from from the space. As you can see, all the GCP is state in this plan and location all so that the client can know where is the location and what is their coordinate. So we go next to the project schedule. So as you can see, all the preliminaries and fieldworks, data processing and reporting process all include in the Gantt charts in the project schedule. So the project started from the June 2017 until the contract expired on the 18 November on 13 November 2018. So all the process receiving started from the receiving letter of award from the client, preparatory work and site visit with the client, site wiki, selection of point, monumenting of second order monument, also GNSS observation and process leveling from benchmark to benchmark, and all the quality checking and all the report is all all put in the Gantt chart in project schedule. And we go next is project timeline. So on June 13, 2021, so the lecturers announced the project 2 to the class, and then to the June 15, 2021, our group began to researching example of the construction and its construction concept use, and we also finding related information about the project report from different sources from the internet especially. And then on June 17, 2021, we do the first discussion among the group on work process and present the sketch of the final product. And we also begin writing the report. On June 19, 2021, we continue working on report, discuss on the progression on report with lecturers, and designing the final plan of tunnel using AutoCAD software. On June 27, 2021, we make final revision and edit on the report and project plans. And we also present final project by recording a 30 minutes video then upload in YouTube. On June 28, 2021, we submit the final report. So that is the scope of work of our group. That's all for me. Thank you.
Assalamualaikum, my name is Muhammad Faiz Akmal bin Zulkafli. For our project, I will continue for the methodology of works. First, we will establish the second order GCP. Second order is used for horizontal control traverse of network when GNSS stands for Global Navigation Satellite System. Survey techniques are enabled to meet the required accuracy. This is typically a project-wide traverse to establish horizontal control for boundary, engineering and construction surveys. If site constraint or weak controls make it difficult to fulfill standard of 2 cm accuracy standard, the only viable way of controlling a project may be a second order crossing. This is typically the case when GNSS surveys are impractical under conditions such as steep side, thick leaves, and tall building. These control surveys are based on pairs of azimuths or other passive monuments of higher order. The main task in this part is to manage the risk relating to effective management of site selection, preparation of, and construction in compliance with relevant first order GCP criteria requirement. The selection of a second order monument is the hardest part in this project. Input from many sources is very helpful in decision making of selection second order location. Next, I will explain about how to establish the second order. We will begin excavation of the perimeter trench by human using spade and hoe. Upon completion of excavation, drive in 4 numbers of 25 mm diameter steel pipe to a depth of not exceeding 0.6 meters as friction base. This has to be confirmed by the consulting engineer from the result of Macintosh probe. Clean the pit from any loose soil, put in plastic sheet, lay in reinforcement, call for inspection or provide photo or video for the work done and get ready for concreting of the footing. Second, stump reinforcement pre-assembled bars are then set to position. The vertically extended length of bars must not be beyond the requirement level and height. Build up formwork and tie-in reinforcement also built. The third one, pouring concrete and fixing in the base holder of the iconic plate, checking the correct level by spirit level. And the last one, get ready for cast in situ, wash stone of pebble finishing to the iconic platform and concreting, and tilting by wash stone of pebble finishing of second order monument according to the client requirement. Next is a control towers. Installation of the station markers of second order using survey, steel nail for horizontal and height control shall be done on tunnel concrete slab at approximate interval of 80 to 100 meter of zigzag pattern, depends on tunnel condition. At the same time, surveyor shall pick up existing control point, brace or pin position during traversing for checking to ensure that the tunnel alignment was built according to the construction drawing. This is the diagram for the zigzag pattern. Next, ordinary traversing with 2 sets of angle at each traverse station shall be carried out along this station marker at 80 to 100 meter interval using Leica Viva TS15A, which is a robotic total station with 1 second angular accuracy, ATR, which stands for automatic target recognition, and 1 mm plus 1.5 ppm distance accuracy. One set of Leica TS15A shall be used with at least 2 precise prism for 2 set of angle and distances measurement. Accuracy for the traversing shall be better than 1 to 10,000. Horizontal control network inside the tunnel shall be adjusted and finalized using standard least square adjustment software. Next, I will explain about leveling. The orthometric height at second order monument will be derived from Malaysia precise gravimetric geode provided by the JUPAM. The GNSS leveling using relative method will be used to determine the orthometric height at second order monument as follows. The orthometric height at the second order monument will be computed from the first order monument using a relative method of GNSS leveling. Figures show a schematic diagram for determination of orthometric height at second order monument using GNSS leveling. The GNSS data observation and parameter will be carried out as shown in table 2 using network solution. The GNSS leveling using relative method at second order monument marker will be compiled with the Director General or Survey and Mapping Circular number 10/2015 as shown in the question 1. Next, least square adjustment and analysis at first order and second order monument marker will be performed to ensure the quality of final vertical component orthometric height as follows. The GNSS leveling using a relative method will be performed from first order monument with second order monument or marker as shown in the figure. One-dimensional adjustment and analysis of loop closure from elevation different for each network will be performed in microsurvey standard least squares adjustment software. Each network with blue dotted line as shown in figure 12, analysis will be produced. The data quality control such as chi-square test, standard error and allowable misexposure will be tested for each network. Precise leveling for the 3 Japan benchmark at each first order monument approximately 20 kilo interval. Next, I will explain about tachometry, or else known as as-built survey. As-built survey shall be carried out to check tolerances of completed structure by the following technique. The use of a laser scanner which emits laser beam at angular interval on a rotating plane either vertically or orthogonal to the tunnel centerline. The use of reflectorless total station by which point outcrop from the tunnel surface are automatically obtained. as-built is one of the survey methods to collect detailed data during the construction. A regal as-built survey was done to check the lining installation. From the figure, Leica TCRA 1103 total station, which is a reflectorless, was used to observe every regal point and all the data was processed. Next, I will explain about the procedure of pickup tunnel profile. First one, Leica TCRA 1103 shall be used to survey the tunnel profile at 10-meter interval using the reflectorless function. Second, each cross-section shall have at least 9 points to represent the shape of the tunnel. Tunnel alignment shall be derived from this cross-section. The third one, tunnel profile shall be done at approximate interval 7 ring or every 10-meter interval. And the last one, total cross-section to be picked up for the entire 10 km is approximately 1,000 cross-section lines. That's all for me. Thank you.
Survey instrument and software. Tunneling survey is underground survey done for constructing a tunnel. The survey done can be divided into two. First, surface survey, and the second one is transferring the alignment underground. Okay, surface survey. Surface survey connects the point in every plotter point in a tunnel. A travel connects the plotter point to determine the azimuth, distance, and differences in elevation of every end of the tunnel. Based on the local situation and purpose, length of the tunnel strategy of operating are adapted. It's constantly really helpful that the survey is primarily based on totally the ideal coordinate system. The alignment is permanently referenced through a system of monument inside a place outside and each tunnel. Second, transferring the alignment underground. A long tunnel excavation is carried inward from both ends, but vertical shafts are also sunk up to the required depth along the alignment of the tunnel and at intermediate locations along the roads. For making the vertical alignment, there are three methods are used. First is plumb bob, second optical collimator, and lastly laser. A heavy plumb bob from 5 to 10 kg is suspended on both a wire heavy twine. Oscillation of the bob may be managed through suspending it in a pot with high viscosity oil. From removable bracket, the bob is suspended and connected to the surface side of the shaft. Second, optical collimator. Optical collimator will become the important component with the increase in depth of interval shaft to allow the establishment of vertical line. Various sorts of plummet are available upwards and downwards. They are usually manufactured so as to be interchanged with theodolites and on their tripods. Lastly, the method that we use to transferring the alignment underground is laser. A laser equipment may be used to provide a vertical line of sight, since the spread of the beam is very small to provide a visible line for constant reference, and the laser will generate a light beam of high intensity and low angular divergence that may be projected along the distance.
Assalamualaikum warahmatullahi wabarakatuh and hi, my name is Arni Shazwani binti Aliza Kafri. So now I'm going to present about the software that we are using for this tunnel project. Okay, now we are moving on to the software that being used for this tunnel project. Okay, there are two software you are using, which is CDS software and AutoCAD software. So for the CDS software, is used to input the data from traverse for each station and then we compute the data. It is also being used to find the data alignment. Okay, so for the first picture, we can see that the sample picture showing that we are imputing the data for each station. Okay, we inserting the value for the coordinate and also the distance. Okay, and for the next picture is how the data will be appear. Okay, we also can recalculate the misclosure. So and also we can show the coordinate here, and then for the next software. Okay, next for the AutoCAD software. So AutoCAD software is used to compile the data from CDS software to create a data block and also to produce the final map plan followed by the standard Jabatan Kerja Raya format frame. Okay, so for the first picture, the sample picture, we are inserting the Jabatan Kerja Raya frame format file into the AutoCAD. Okay, so and for the next picture is the sample of the output plan of the tunnel. Okay, which is we already compile the data, the all data, and then we will produce this output final plan for the tunnel. Okay, so next.
Assalamualaikum and salam sejahtera. So we continue our presentation of our project with a final product or plans. So as you can see on the slide, there are sample output of the tunnels. You can see the tunnel connect to station from G1 area to G2 area. So as you can see, this is a sample output and the output consists of the alignment or information that show the alignment of the tunnel. So we go to look at the G1 first. So this is the final output from G1. As you can see, all the information about the tunnels can be present in the final output to the client. So since this is the final output that need to send to the client, frame the frame need to follow according to the standard that has been established. Same goes to the final output plan from G2. So it's need to follow the standard that has been established and also the layout. That's all for me.
Last but not least from our group, for the summary, using the underground speed train is a brand new innovative approach in the city transportation system. Even in the making of the tunnel, it takes a lot of time to complete it, but with the technology and production method developed followed by the time, all of it turned out to be more easy than before. Nowadays, technology is so advanced and efficient. This technology provides us a lot of benefits to assemble the tunnel. From our research, the underground speed train from Iskandar to Klia 2 has proven a brand new step taken by our government to improve and follow the modernity of the transportation system. So, in conclusion, The underground speed train evolution as one of the modern transportation systems for underground give a big impact to the country and consumers. Furthermore, it is also give more attention to engineers out there to take this opportunity to improve more in these developing countries. That's all from our group. Thank you.